This is Jack Jackson back again with another video on the SSA situation. So let's look at this example here where we have a side of length 4, a side of length 5, and an angle of 52 degrees. Okay, so this is an SSA situation. So this would be written as a 4 centimeter, 5 centimeter, 52 degree triangle. Notice that this side and this angle right here must be opposite. This is different than a 4 centimeter, 52 degrees, 5 centimeter, which is a side angle side situation. So we're not doing that one, we're doing this situation here. So to do this, we're actually going to do it this way. We're going to start by getting the angle, then the adjacent side, and then the opposite side. So we start by constructing the angle there. There's our angle A. Next, we're going to construct the adjacent side. So we're going to go out actually on this ray here, and there's our adjacent side with a length of 5 centimeters. Then the last one we're going to get is actually the first one listed, the 4 centimeters, the opposite side. So we're really going to do this more as, think of it as ASS rather than SSA. So we've got 4 centimeters here, and so we're going to, if we're doing this with our compass and protractor and ruler, well, we would start by making that angle with our protractor, then marking out on one side with our ruler. But to get the third side, what we do is we set our compass to the length of, in this case, 4 centimeters, and make that a circle centered at C, and the place or places that it crosses the ray down here at the bottom are going to be your possibilities for B. Okay, and we get actually two different possibilities for the angle at B, and notice those two different possibilities are they are supplementary. That's not good. They are supplementary, so if we add those together, let's see if we can calculate that. B1 plus B2, you always get 180 degrees if there are two possibilities. So in this case, there's one triangle that's uses B1, that's the larger area, has an area of 7.42 square centimeters, and notice that it's using these for the sides out here and down here at the bottom. Okay, and it uses this angle right here for B1. Okay, and that is 80 degrees. Okay, whereas the angle up here at C is the larger of the two little angles here at C. It's actually this one right here, about 48 degrees. And then the side along here is actually the longer side from A to B1, call that C1. That's about 3.8. But there's another triangle. The other triangle is over here, smaller area, 4.71 square centimeters, larger angle at B2, about 100 degrees, and the side C2 here is shorter from A to B2, about 2.4 centimeters, and let's see what else. And the angle up here at C is a smaller angle here. So if you want to compare these side by side, the A, the B, and the angle A, side A, side B, and angle A are the same between the two. They share the angle A, they share the side B, and these two sides at A are congruent, but everything else is different about the two. And as with the other situations, at the end of the course we'll come back and learn something called the law of sines and law of cosines, which will allow us to solve for these things and more computationally, algebraically, numerically solve for them. The idea here at this point is just to be able to construct the things and measure them. So here's what we're going to do. We're going to practice again and see what comes up with this. So let's just make up some examples. We'll do several examples here. Suppose you have a 2 centimeter, 8 centimeter, 70 degrees. Okay, construct that one if possible, and tell me if there's, if it's not possible, that's fine. If there's one case that it works, that's fine. If there's two, then tell me both of those cases. But completely solve this and tell me what happens. Actually do it yourself, and then come back and we'll do it here, and you'll be able to check your work. So get your protractor, your compass, and your ruler and pencil and paper out and try this yourself, and come back. Press pause now. Well, you're back, and again, so let's set this. First, we set this to be our 72 degrees, 70 degrees, excuse me. And then we set the side next to it, so that's the first thing we do. Then from there we draw out the 8 centimeters. And then finally we put the last side in, which was 2 centimeters. And we see this is one of those cases where we take this point right here and no matter where we put it on this circle, it's not going to be long enough to fit down here. So this is a no solution case. So it's not possible. We could get this far with our construction, and then we see that it's not possible. Okay, let's try another one. 3 centimeters, 4 centimeters, 37 degrees. Let's try that one. Okay, press pause. Do it now. Okay, you're back. Let's try it again. Let's try 37 degrees here. And let's try, then next to that, the adjacent one was the 4 centimeters. That'll be the blue one. And then the next one was 3. And we see that there's actually 2 possibilities here. That line touches twice. Okay, and we see that there is one whole set of things is this bigger triangle here. So that would go from A to C to B1 here, and that's going to give us these measurements for the other sides and angles. On the other hand, you could look at this smaller area triangle, one with the bigger angle at B2, and this is what it measures out to be. So you should have come up with 2 completely different sets of answers for this. So you should come out about 54 well, let's do triangle 1, bigger triangle, acute angle at B. That angle turns out to be about 53 degrees, which makes the angle up here at C, from A to C to B1, that bigger angle there, that makes it about 90 degrees. So we about have a right angle there. And then we have then the C is from A to B1, that length is about 5 centimeters. So it's about a 3, 4, 5 degree triangle. Okay. Alright, now what about triangle 2? Triangle 2, we can see is here. The angle here is bigger. It's about 127 degrees. This distance here is shorter. It's only 1.4 instead of about 5. And the angle at C is smaller too. It's only about 16 degrees instead of being 90 degrees. And smaller area as well. Okay, let's try another one. Okay. Okay, let's try this. Oops. let's see, how about 9 centimeters, 5 centimeters, 40 degrees. Try that one. Press pause and then come back later. Okay, let's see what this one turns out to be. So you start by making your 40-degree angle. Then you do your adjacent side, which is 5 centimeters. And then you do your opposite side, which was 9 centimeters. Now notice, this one I could have predicted ahead of time before we ever did it, that this side here is longer than this one here. The first one's longer than the second one. Anytime that they're the same or longer for the first one, you're only going to get one solution. So it says triangle 1 and triangle 2, but really it's the same triangle if you look. So it's really just triangle 1. There's really only one triangle. And there it is. And there are the measurements. So what you should have gotten a triangle that looks like this. You should have gotten about 21 degrees here. You should have gotten down here for side C, you should have gotten 12.2 centimeters. You should have gotten then 119 degrees at the top. So when you're doing these for the homework, you're going to have to be able to do this accurately enough to get your answers within 0.1 centimeters on the length and within 2 degrees on the angle. So on the homework problems in my math lab. So if you had this problem on homework in my math lab, first of all, you'd have to recognize that it's a one possibility solution, and you should have gotten, I would take 12.1, 12.2, and 12.3 for this, for down here, and for the angle here I would have taken 118, 119, or 120 degrees for the C, and for the B down here it would have been 20 degrees, 21, or 22 degrees. It would all count those right, even though it should be really 21 degrees. Okay, let's try another one. Okay, so this time let's try 2 centimeters. Well, let's try, no, let's not try that. Let's try, let's let 3 centimeters be the adjacent side, 6 centimeters be the opposite side, and let's go for 30 degrees. Let's try that one. Okay, see if you can work that one out now. Okay, press pause now. Okay, well you're back. Let's try this again. So I'm going to put the 30 degrees in there. We're going to put the adjacent side was 3. And the opposite side was 6, and we get that to work out like that. Again, this is one where the first side is bigger than the second one. So these last two were big S, little s, A, so we know that there's really only one triangle. If I put this, it's the same triangle again. So your measurements should have been, to check them, at B, you should measure that out about 14 degrees and measure at angle C to be 136 degrees, and the side C at the bottom measures out to be about 8.4 centimeters. Now, the order does make a difference here. Okay, what if we change it to 3 centimeters, 6 centimeters, and 30 degrees? Try that one now. Press pause when you get it done, and come back when you get it done. Press pause now. Okay, so now let's switch this. 3 and 6. Alright, and this is a case where this side is just right in the sense to have 1. If it was any shorter, there wouldn't be a solution, and if it was just a little bit longer, there would be 2 solutions. But here there's one that's just right to make this line and this circle tangent to each other, and so we have a right angle here, and so that's a 90-degree angle there. So that's 60 degrees for the other angle, 30 for this one, and this side down here measures out to be about 5.2 centimeters. Okay, I think we've done at least one of every example. One where there was a right angle, one where it was too short and there was no solution, one where it was longer. Let's do just one more. So I haven't given you one with an obtuse angle. Now, if you've got an obtuse angle here, the opposite side has to be here. So for this to work, well, if I say 3 centimeters and 8 centimeters, I know this is not going to work because this is the opposite of the biggest angle. This has got to be the biggest side. But what if we make it a little bit bigger? What if we make it 13 centimeters and 8 centimeters? That will work. That's the big S, little SA situation. So if this is an obtuse angle, you're either in this situation or else it's just you're in the no solution situation. So go ahead and construct this one just so we get some practice with an obtuse angle too. Press pause now. Alright, so that one's an obtuse angle coming out here, and 8 centimeters for the close side. Let's see, move it over, we can see it. And then the long side was 13, and it does come back and touch here. And so there's your triangle, and there are the other measurements. So for angle B, you should have gotten about 28 degrees, leaving angle C to be about 19 degrees. And the length of this side here at the bottom, at side C, was about 6.3 centimeters. Okay, I think that's enough examples now. You should do many more of these till you practice and get comfortable working with your compass, your protractor, and measurement, your ruler, and then also just get comfortable with these different situations and being able to do these and measure them. So remember, you can open this Geometry Sketchpad sketch yourself and try some yourself first, and then put the numbers in here and have it calculate them to be a nice check. So you can check in any of these cases that we've looked at so far: side, angle, side, 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 angle, side, angle, 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 side, and side, side, angle. So we've got angle, angle, side, and side, side, angle. We've got one more situation to look at next time, and that's where we're given the angles.